Okay, so we're going to talk about Chapter 9, Section 1, Wave Action, and we're going to watch a portion of a Study Jams video that introduces waves.
Oh man, I almost had it that time. Those waves are so powerful. I can barely balance on the board, let alone stand up. Yeah, and they aren't even that big. Imagine what a tsunami is like. No way, man, those are scary. Aren't they caused by earthquakes or something? Yeah, a tsunami is a series of waves caused by an underwater earthquake, landslide, or volcano. Those things can destroy a whole city. Where do waves get all their power? I mean, I know waves get bigger when it's windy, but there's got to be more to it than that. There is. Waves are really just the up and down movement of energy on the water's surface. Wind, volcanoes, earthquakes, landslides, they all cause waves.
So, what causes waves to form? Wind blowing across the surface. Now you noticed in the video there were other things that causes waves to form also. In this case, a majority of our waves, or a lot of our waves, come just generally from the energy of wind transferring to the water particles as it blows across the surface. Number 2, what is a wave? A wave is a movement of energy through a body of water. If you think about the wave at a football stadium, you will notice that the energy moves through people. The people don't actually do anything but go up and down in the stadium, but the energy moves forward or to the side of the person next to them. So a wave is a movement of energy through a body of water. A lot of students like to ask me what this is. This is actually a method of gaining energy. These buoys go up and down with the waves, and underneath they're attached to little generators. And so as they go up and down and up and down, the little generators get electricity, or generate electricity. So this is just a way to gather energy. If you were in a submarine, and I'm sorry you can't read the top portion of that, but if you were in a submarine, why couldn't you tell if it was rough or smooth on the surface? That's because a wave's energy only reaches to a certain depth. Water does not move as a result of wave action below a certain point. And this particle is going to go up and down, and it's going to have a lot of energy. And the next one below it is going to go up and down and have a little less, and then a little less, and a little less, and a little less, until you get to a certain depth that you don't feel any energy at all. So you could have a lot of things going on the surface of the water that people in a submarine would never be able to see. What is the crest? When we dissect a wave, if this were a wave, or it is a wave, but you will see at the very top of the wave, these top edges are called the crest. It's the name for the highest part of the wave. The wavelength is the distance between the crests. So from crest to crest you have the wavelength. It can also be measured from, it can also be measured from trough to trough as well, because you can see these are equidistant. This is the same distance from trough to trough as it is from crest to crest. Frequency, this is how frequent a wave passes a certain point. I like to think of this little pelican sitting on the side of this dock, and he's counting how frequent the waves passed where he's standing. And so he's counting 1 wave, 2 wave, 3 wave. So that's the frequency, how frequent a wave passes a certain point. A trough is the lowest part of the wave. If you can see, this is the trough. This is the deep part down here. So this is labeled the trough, and it kind of resembles like a horse trough that you would have that holds water. So this little deep part is very similar to the deep part here that's filled with water. So the lowest part of a wave is called a trough. Wave height is the distance from the crest to the trough. That would be the wave height. The distance from the crest, the highest point of the wave, to the trough, which is the lowest part of the wave. Undertow. This is the pull of the water as it rushes back out into the ocean. A lot of times the beaches will put flags up notifying people that they can't go out in the water because the undertow is too strong. We know that the water, as it topples on the beach, eventually gets pulled back out into the ocean. And that pull back out into the ocean can be so strong that it can make it very dangerous for swimmers. Rip current is a rush of water that flows back to sea through a narrow opening. A rip current is usually locational, where you would have two sandbars, okay? And the sandbars, and I'm not sure this is going to let me write. We're going to try and write here. All right, so I have one sandbar here. All right, it might extend out a little bit. And then I have another sandbar here. Extends out a little bit. And what's going to happen is, let's see if this lets me change my color, that the water comes over top. When it comes into shore, it comes over top of these sandbars. And I'm going to change my watercolor to something we could see a little bit better. Okay, so the water comes into the beach and it comes through all this area. Comes over top of these sandbars. It's got so much energy. But when it goes out, it doesn't have enough energy to go back over the sandbars, and so it just goes through that narrow opening. I'm going to change the pen color to represent what it looks like when it goes back out. Let's change it to yellow. So it just goes through this narrow opening right here when it goes back out. So all this water is rushing back between these two sandbars. And many times people can get caught in this sandbar. If you find yourself ever to get caught in one of these, the best thing to do is either ride it out, which is kind of scary because it's scary to get far away from the beach, or they always teach swimmers that if you're ever caught in a rip current, to swim diagonal. So if you are, let's pick the little pink person right here, okay, and you are caught in a rip current, you're going to exhaust yourself swimming against this rip current. So the best thing to do is swim diagonal over here, and you'll find you'll get out of it a lot faster. Many cases too, you'll find if you swim diagonal, you get to that sandbar and you'll be able to stand up. So if you're ever caught in a rip current, either ride it out or swim diagonal, and you'll get out of the it. If you just keep swimming straight through it, you're going to exhaust yourself because all this water is going to keep pulling you back out into the ocean. Okay, so that's it for all our notes today. And we're going to make sure these get in our pocket folders. And then you have a worksheet to do that goes with these notes. Have a good day.